Okay, we've been given the amount of money in investment is modeled by this function. A is going to equal 650 times 1.0886 raised to the t power. Now I've also gone ahead and included the compound interest formula over on the right hand side because this is a formula most of us are comfortable with or have seen somewhere along the way, and we're going to kind of line up some of the components between the one that's given and the general compound interest formula. All right, A is going to represent the invested balance in dollars. A lot of times we say this is the accumulated amount. And T is the number of years since 2005. So we'll go ahead and make note of that. It's years since 2005. So in 2005, the balance was, fill in the blank. Well, the balance in 2005 was 0 years since 2005. So that's when time is equal to 0. Or another way to think about it is it's the initial investment. It's how much you started with. All right, so the first two questions on this are basically asking the same thing. P, up here, we refer to that as being the principal. It's the amount that you open the account with, the amount that you start with. And you'll notice it's the number out in front that's not raised to the exponent. Well, the same thing can be true over here with the 650. So our balance in 2005, well, we started with $650. The other way to come to the same conclusion is we can fill 0 in for t. In this case, it'll be 650 times anything raised to the 0 power is 1, so 650 times 1 also gets us back to 650. Now, the amount of money in the investment is at time 0 in 2005. We can answer that that's going to be $650. If they ask for other specific years, well, we can go ahead and fill in different values for t to figure that out. Okay, the annual rate of change in the balance is, well, in this case, what we want to do is they've told us they want to know the annual rate of change. If we're talking about annual rate of change, n is going to be 1 in that generalized formula over on the right-hand side. So let's ignore the 650 and p. We don't need to worry about that. Instead, let's think about if we plug in 1 for n, we have 1.0886 is equal to the base over on the right-hand side, 1 plus r over 1. All right, so those are going to have to be equal where we plug in 1 for annual rate, but really that's the same thing as 1.0886 is equal to 1 plus r. We have an equation. We want to be able to solve for r. So we'll simply subtract 1 from both sides and get 0.0886 is r, and r represents the rate in this formula. So r is 0.0886, or as a percentage, what we would do to get to a percentage is we'd go 2 decimal places to the right to go from decimal to percent. So equivalently as a percent, that is going to be 8.86%. And then final question on this one, in the year 2000, the investment balance will equal what? Well, 2009 minus 2005, because t is years since 2005, so 2009 is going to be 4 years since 2005. That's going to be our value for t that gets evaluated into this function. So we can say A is going to be 650 times 1.0886 raised to the 4th power. This is where we would want to get our calculators out and figure out this works out to be 912.823. Now in this case, it's a banking problem. Typically what we do in banking problems is we round to 2 decimal places. That's why I've listed out the 3rd decimal place. Because that's below 5, we're going to round down, keep it as 2, as opposed to move that up to 3 cents. So let's get rid of that, and we can say $912.82. All right, hope this helps out as you're working through some of these exponential functions. Good luck.